Hello everyone, my name is Qiwei Wang and I'm a student in Civil 745. Today I'm going to do a set investigation about the UM building in New Zealand. The main purpose is to discuss and evaluate the safety issue of UM building in earthquakes and the stability of the buildings themselves. The location of the target UM building is 43 Wyndham Street, Auckland CBD. First of all, the tools I used in this set investigation is a tape measure and the mobile phone rangefinder, because the height of the building and the roof cannot be closed to the specific measurement, so use the mobile phone rangefinder to estimate. Generally speaking, the error is within a lowball range. Before this activity, I have already filled the health and safety forms and make the comprehensive preparation. That includes the traffic plan, risk controls, and so on. The transportation mode I choose is by bus. The specific route is to take the North Shore bus, take the Highway 1, get off at the station near that building, and then walk for 5 minutes to reach the destination. The weather conditions are good. There is no need to consider factors such as rain, slippery ground, and so on. Let's go to the point. The target building is located at the intersection of Hobson Street and Wyndham Street, in the central area of Auckland. Terrain is relatively gentle with no significant gradient change, so we don't need to consider the slope stability analysis, and there is no falling hazards due to rockfall or landslides. In addition, there is no evidence of potential for liquefaction or lateral spreading. The soil class is Class C, shallow soil site. Then let's come to the neighbor buildings. We can observe that there is no structurally connected with other buildings, so it is an isolated UM building. There is a church about 50 meters to the right of the building, and also another UM building is 6 meters to the back facade of the target building. Due to the relatively long distance away from the neighboring buildings, so there is no likelihood of debris falling onto the buildings from its neighbor. Next, it's about the wall morphology. Ventilation is one important feature of UM building. There is clear evidence of ventilation gaps on the outer side wall of the building. After the observation and measurement, the brick is the most common nominal size of clay bricks used in masonry buildings, with 230 mm in length, 110 mm in width, and 70 mm in depth. The masonry bond pattern is English bond, and after the measurement, the thickness of the outer wall is around 400 mm. Due to the fact that it is not possible to measure and investigate inside the wall. It is assumed that the outer wall is consisted by 2 layers of brick with a 60 mm cavity in the middle, and the first layer is English bond with 230 mm, and then it's a cavity with a 60 mm, and behind the cavity, the bond pattern of second layer is running bond with 110 mm. And for the inside wall, because it is impossible to go inside to the building, so it is assumed that the inside wall is 2-leaf solid wall with 230 mm. Bond pattern is normal running bond. And then comes to the potential non-structural falling hazards. There are 4 gables in total, 2 on the front facade, and 1 on the side facade, and 1 on the back. Roof inspection is not possible at that moment, but by observation, there is no parapet on the roof, and the roof material is tightly distributed and show no signs of losing or falling off. According to the site investigation and Auckland Council geomap, there are 6 chimneys in total. 4 of them can be clearly observed, 1 on each side of the entire building. In addition, 2 chimneys are located in the middle position of the roof and cannot be seen due to the pointed edge design. 4 other chimneys are spread out around the roof. Then, it is about the chimney size and the lintel. The chimney size is assumed 0.5 meter in width and 1.5 meters in height. The thickness of the chimney wall is about 80 millimeters, and the chimney is made of concrete. For lintel, due to the point edge design of the door and the stone decoration of the windows, lintel is unable to see clearly. Here, it assumes that the ordinary rectangular lintel is calculated. The specific data is the lintel depth corresponds to 4 courses of bricks, and assume lintel is 4 wall depths. Then let's come to the machinery materials. Obvious motor information can be observed on the wall of this building. Due to the special design, it is assumed that all the parts are consistent with the main building as English bound. In some places, the motor has been repointed. The repointed place is concentrated in the lower part of the outer wall, and the repointed place of the motor harness is rated hard. For the place of motor harness that has not been repointed is rated medium level. Scratches with a fingernail, only for the uneven motor place. Here refers to the motor protruding outside the wall can be raked out by finger pressure. But the overall harness is medium level. In addition, for no repointed place, there are also some mossy plants that grow on the surface, which is also a factor in the strength reduction of motor. After the evaluation of the machinery material, based on the table and equation in unreinforced machinery building C8, we can get the data for the motor and brick properties. The subsequent values were presented in the site investigation report. For the diaphragm stiffness of the building, due to the fact that it is impossible to enter the building and the material information cannot be accurately observed through the windows, it is assumed that the material of diaphragm is timber. Timber is generally in good condition. The specific performance of timber is free of bore. There is no signs of water damage, no rusting of nails, and no separation of floorboards. Based on the tables in unreinforced machinery building C8, we can get a loading of parallel to joints and perpendicular to joints. The specific values were presented in the site investigation report. The specific numerical information is that the total length of the front facade is 18 meters, which is divided into 3 parts, 5 meters, 8 meters, and 5 meters from left to right. The total height of the building is 10 meters, including the normal height of 8 meters and the point edge height of 2 meters. In addition, it should be noted that one area of the building is enclosed by a fence. So, it is assumed that the building is a symmetrical structure because it is inaccessible, and the length, width, and height information on both sides are consistent. The numerical information for the window is 3 meters high and 1 meter wide, and surrounded by carved stone decorations. The numerical information of the door is 3.3 meters high and 2 meters wide, and surrounded by carved stone decorations. This is all the information I got from site investigation. Thank you for watching.